Hello Prof, this is Group 5's DDW 2D project. Our problem is that the food prices in the United States have been increasing over the years, to the point where there is a problem for some consumers to afford food. If food prices can be controlled by the United States government, they will be able to ensure food availability for all of the citizens. Thus, we will want to find out which factor has a high correlation with food prices so that United States government can regulate food price. For our problem statement, it is how might we better manage the consumer price index for food in the United States by analyzing past data for various socio-economic or environmental predictors and indirectly targeting those that are statistically significant. For the preparation of data, we searched for data in the United States and collected the data for the years that overlaps in a single sheet. Checking that there is no missing data, we saved it as a CSV file, taking out the year and country column. Using Pandas library, we can read the data, and by using the describe function, we can see the summary of the respective columns. Seeing as to how carbon dioxide emissions are in the billions and the agricultural land is in percentage, we could simplify the data later on. The features used will be the independent variables: carbon dioxide emissions, temperature, mean annual inflation, unemployment rate, and agricultural land use. This is the reasons why we use these features. For carbon dioxide emissions, is one of the main factors that directly affects crop yield. Generally, the increase in carbon dioxide emissions due to industrialization intensifies the conditions brought about by climate change, which may result in reduced agricultural productivity. Our hypothesis is that the supply of food crops will be disrupted with greater CO2 emissions, therefore increasing the consumer food price index in the United States. For temperature, an increase in temperature due to trapped greenhouse gases has shown to produce fewer crop gains and smaller yields due to a drop in photosynthesis. A fall in the supply of crops could then increase the consumer food price index. For mean annual inflation, it is a measure of the rate of increase in the price of goods and services over time. We want to then investigate how a change in inflation across all goods in the economy would directly affect the consumer food price index specifically. For unemployment rate, it influences the proportion of the population that has the purchasing power to purchase more food. A decrease in the unemployment signifies increased purchasing power of an economy, which drives up demand for commodities and in turn price, therefore increasing the consumer food price index. Agricultural land is the percentage of land that is dedicated to agricultural growth. We chose agricultural land as one of our predictors, as the United States heavily relies on their own agricultural produce and produce 85% of their overall food supply. We also assume that a change in percentage agricultural land use signifies a similar direct change in the actual agricultural land size use. Hence, a decrease in percentage agricultural land use could lead to an increase in consumer food price index. To first simplify the data, I converted the carbon dioxide emissions column from in tons to in gigatons, and converting the agricultural land use from a percentage to a decimal. We have a get features targets function that returns the feature and target. Next, we split the features and target to training and testing sets, where the train set will be used to train the multiple linear regression model, and the test set will be used to evaluate the accuracy of the model. To build the linear regression model, I will first initialize the beta to match the number of columns of the feature so that the matrix multiplication can go through, as shown here. And then I will call the gradient descent function to find the coefficients for the model stored in the variable beta. For evaluation of model, we will be using R-squared and mean squared error. For R-squared, we will see that it is close to 1, thus showing that the model is quite accurate in predicting the values. For mean square error, the lower the value is to 0, the better. And we will use this to gauge if the improved model is a better fit. By scatter plotting the test target values and predicted values, we can see that the data points for the target values and predicted values are close to each other. Now, we'll move on to improving the model. For multiple linear regression, we want to reduce multicollinearity of the independent variables. By plotting a heat map of the correlation of the features, we can eliminate the independent variables with high correlation to each other. The values closest to 1 suggest a high correlation. And we have decided to take away both carbon dioxide emissions and temperature. And this is the heat map that we're left with. Now we'll repeat all the steps that we used from above without CO2 emissions and temperature. We can see that the R-square value have increased from 0.926 to 0.929. This shows that the multiple linear regression model is a better one as it is closer to 1, signifying that it has a higher linear relationship. And our mean squared error has also decreased from 500 to 443. It shows that the error between actual and predicted data is decreased. From the beta values, we can determine the equation of the multilinear regression model. Beta 1, which is negative 66.3, is the coefficient of agricultural land, so an increase in 1 unit of agricultural land will decrease the consumer price index by negative 66.3. This shows that the percentage of land used for agriculture significantly affects the consumer price index for food, due to agricultural land being tied to the supply of food. With less agricultural land, the supply of food will decrease and the price of food will increase. Thus, if the United States government can control areas used for agriculture, they will be able to control and stabilize food products.